Welcome back, ladies and gentlemen. We now proceed to session 3, stressing on the theme of advancements in Counter-UAS Grid. To chair this session, we have Lieutenant General Vipul Shinghal, AVSM, SM, Deputy Chief of Integrated Defence Staff, Doctrine, Organization and Training. May I request the General to please come to the stage.
Thank you.
Thank you, sir. To co-chair this session, we have Shri Mukesh Singh, DG ITBP. May I request Shri Mukesh Singh to please come to the stage. Thank you, sir. I extend the invite to our esteemed panelists for this session. Please join us on stage, Mr. Navneet Singh, CEO, Kepler Aerospace. Major General C.S. Maan, AVSM, VSM, ADG, ADB. Let me introduce the chairs and the panelists. Lieutenant General Vipul Shinghal, AVSM, SM, Deputy Chief of Integrated Defence Staff, Doctrine, Organization and Training, has over 36 years of distinguished service in the Indian Army. He was commissioned into the Armoured Corps in 1988 and has commanded an armoured division and an independent armoured brigade in the desert sector. He has held key operational and staff roles including Major General Staff Operations at the Command HQ and Director at the Strategic Planning Directorate. A decorated officer, he has been awarded the Sena Medal for his exceptional service and has also served as Secretary of NDC, New Delhi. Shri Mukesh Singh is a senior IPS officer with expertise in counter-terrorism, law enforcement and national security. He has held key roles including IG ITBP and ADG Jammu Province. During his tenure with the NIA, he led probes into major terror attacks including 2611 Mumbai, Pathankot Air Base and Pulwama CRPF attack and headed the terror funding and fake currency cell of the NIA. He also contributed to FATF projects on terror. For his service, he has received multiple gallantry and meritorious service medals, including the Police Medal for Gallantry thrice and Sher-e-Kashmir Medal for Gallantry. Navneet Singh is the CEO of Kepler Aerospace. Prior to this, he worked as a system engineer at ISRO, specializing in small satellite development at the IRS office. He holds a bachelor degree in aerospace engineering from Embry-Riddle Aeronautical University. Major General C.S. Maan, AVSM, VSM, is the head of the Army Design Bureau. He plays a crucial role in driving digitization and technological advancements in the Indian Army. Commissioned into the Armoured Corps in 1990, he has commanded an armoured regiment and an independent armoured brigade in the Western Theatre. He has been an instructor at ACCNS and has attended the Defence Services Staff College and the Higher Defence Management courses. I once again welcome the esteemed panelists on stage. Speakers are requested to kindly adhere to their allotted time. A buzzer will sound 2 minutes before the time limit as a cue to conclude. I now hand over to the chairperson.
Good afternoon. I'm slightly, I have a throat problem, so maybe the level of the voice is not as good as it should be. Just to give a sort of backgrounder into the focus on counter-drone solutions which we have now, let me take you back to 2019. Till 2019, what we had heard of on the drone front was the event management drones in India, the drones which were used to hit Taliban targets precisely by the US, a bit of drone usage in Turkey, Syria, and Iraq. I was not aware of anything more than that till that time, when a source came up and said that they are asking for a latitude and longitude. I said, why, what for? They said they'll drop a weapon there. Till that time, I had only heard of the Purulia arms drop case. I said, they'll drop a weapon on the exact lat long. He said, yes, that is what they're claiming. So we sent a team of policemen and the 9 para special force, because they had the thermal imager cameras. They went at 2 in the night. They stood there at the lat long. They didn't notice anything till the drone actually came over their head and dropped a packet of weapons. So that was the first instance in 2019 end. 2020 Jan 2019 end. That was the first instance. Since then, drones started coming in from across the border in Samba, Kathua. We intercepted some through source intelligence information, and we could not intercept many others which went to the Kashmir Valley. Now the change started in 2021 June, when they dropped a bomb at the Jammu Air Force Station. Now this was a serious affair. The distance from the nearest international border location was 14 kilometers. So therefore they had the capabilities of dropping something at around 15 kilometers distance and at a precise location. They could have dropped it on the helicopters too, which came up during interrogation of a person later, that their intention was not to drop it at the helicopter. Their intention was to show them that we have the capabilities of doing this. Now this was in retaliation to another incident which happened in Pakistan, which we should not be discussing too much in detail. Now, then the focus started. We started hurrying through possible anti-counter drone solutions because we needed something at the Jammu airport. So we looked at all over India, whichever organization had whatever counter drone solutions, and there was one organization, the NSG, which had one such system with them. They came to Jammu airport, they stayed there for a week. Now the terrorists won't send a drone every day. So they came there, they demonstrated their system to us. It was a decent system, but only for a management of an event in a radius of 3 kilometers. So they could detect something which would enter a 3 kilometers radius, and they would possibly neutralize them at a distance of 800 meters. The hard kill gun which they had had a range of 800 meters. Now in 2023 January, when there was a VVVVIP event happening, they said that they will drop a bomb at a police naka, which was around 18 kilometers away. So they said that we have now better capabilities. So they were evolving. And then we were like panic situation. Air Force was there, the Army was there, we were there, BSF was there. We deployed whatever was possible with us. So the jammers were there, GPS blockers were there, everything. So the Udhampur Air Force Station had a 40-kilometer distance GPS jammer. The Air Force Station, Jammu had something, so BSF had something. Army also had a 10-20 kilometers distance jammer. So they deployed everything possible. And at around 2 o'clock in the night, our source was in conversation with the commander of the terrorist group across. He said that there is some problem. The drone took off from Sialkot. It came up to the border and then developed, the GPS got blocked. So therefore something worked. So that is the level at which we were that time. Now since then, a lot of water has flown into the river. The drone technology has improved. The counter-drone technology has definitely improved. There was an army system, the DRDO developed system which the army had that time. We tried that on one day where we had a specific information. They were supposed to drop 5 sorties. They dropped 4 successfully, despite the deployment of the counter-drone solution there. And on the 5th sortie, they said that we have a problem with the system, and now we can't fly, so the last sortie won't come. So that was a partial success of a counter-drone solution deployed there. Now, since I have limited time, I will not go into my colleagues, because colleague had prepared a PowerPoint presentation that will take some time. I'll just talk about some challenges along the border at high altitude. Since now I'm with the ITBP and looking at the China border. In the past 5 years, we have had around 70 transgressions through unmanned aerial systems into our area. And we have not been able to neutralize any so far. We ourselves have tried, not us, but the army, have tried once or twice in some disputed areas where we wanted to get in and see what was happening across, and the drone got lost, and we could not recover the drone. So that is about the counter drone and drone problems at the border. The problem with the high altitude area is, especially places like Arunachal, is that one, they are not connected by road. So we cannot deploy a big, huge vehicle mounted counter drone system, because there are border outposts which are 90 kilometers away from the border, from the roadhead. How will you deploy those systems? The man-pack systems have a limited capability. They have a limited battery life, and they have a limited range. So you cannot be expecting every border patrol to go out with a man-pack and counter drone solution. So that is the other problem. The third problem is that at high altitudes, the battery life is limited. So unless it is a fuel-based counter-drone system, the battery-based counter-drone system, every around 1,000-meter altitude, the battery performance goes down by 10%. That is the approximate calculation. The people from the industry will know better. So that is one big challenge for any counter-drone system which is battery-operated at high altitude. Then if you have an acoustic detection system, there is a limit of, because of the wind speed and all, there is a lot of noise, background noise, so acoustic-based systems won't work that much. In places like Arunachal, where there's half the time or 70% of the time in a year, you have dense clouds, fog, this, that. So any such solution will have a limitation there. So all kinds of challenges we are facing at the line of actual control with China, especially in high altitude areas, to have a counter drone system. The net result as of now is I'm not aware of any successful counter drones attempt at the China border. On the other hand, we have lost some of our drones which we try to fly along the line of actual control. That is all about the challenges we are facing as of now. I would request if anybody else has more inputs into these systems, I'll be happy.
Thank you. Yeah, we can have the next speaker, Navneet. Yeah.
Thank you to my previous panelists for basically summarizing my entire presentation. But I will still try to make it interesting. I'm Navneet Singh, and I'm here to talk about comprehensive counter-UAS solutions in a grid architecture rather than a singular one-off system, because as he has made it quite clear, single systems do not actually work perfectly well in a contested as well as a environmentally variable region. So first I will go over the actual gist of my presentation. The first problem is EW is a cat and mouse game. You have ECM, the enemy has ECCM, then you do ECCCM, and it continues to the nth power. So the point is that EW is a constant cat and mouse game, and to stay ahead and to counter people who are continuously making systems that can work in actively denied environments is a massive sum game. I mean, we can go downstairs and see a couple of drones that clearly talk about how they are still operating in Ukraine even under intense EW environments. So a battlefield is a pure Darwinism environment. The best and the adaptable survive. You have to keep adapting, and that's why on-the-fly innovation, especially at the unit level, is a major criticality. You cannot expect R&D to happen at the speed at which the battlefield evolves unless and until the people utilizing the system, the user themselves, is involved in the R&D process. So that's where we come to the second point, empowering the users. The user has to be empowered to be able to not only work with the system, but also work with the manufacturers, to work with the industry, to ensure that the latest issues that are plaguing the battlefield, that are plaguing the systems at the front, are communicated as well as worked upon together. Quick iterative development and changes are required to ensure that counter-drone solutions do not become a target themselves of enemy action, as well as latest advancements at the front in enemy drone actions are communicated to the, actual R&D people in the background. And third, as he brought out a point very, very succinct, is that your counter-drone system has to run off fossil fuels. You can't use batteries, you can't have backpack mounted systems because of the terrain, because of the altitude operations and limitations. That's a very important point, because what we and what I have been proposing is a networked approach to anti-drone systems. Some things may work against some drones, some things may not work against those drones. But when you have a comprehensive, combined approach to an anti-drone system, that is the only way things will happen. And that has to have, and especially in today's era, where drones such as FPV drones are all the rage in Ukraine, GPS-denied autonomous navigation drones are all the rage with computer vision aided systems, you can't jam those drones. You either have to take them down with kinetic kill measures, or you need to use some kind of a high-power microwave-based system. But in the end, the problem remains. The enemy will counter what you're doing. And you can see videos of on-ground situation where soldiers have tried to take down drones with shotguns at close range. Russians have created an entire array of shotguns on vehicles to take down drones, but the enemy finds a way. So the point here is there has to be a combined, concerted, networked approach to how to counter from the smallest UAS to the biggest UAV. So now, as I told before, you need to ensure that your counter-drone systems do not become the target of enemy action themselves. As you can see in this image, there are few images talking about in-field modification and the pace at which the enemy cat and mouse game happens at EW. In the top, you can see a FPV made by using cardboard in the trenches of Ukraine, and the same drone being able to take out an entire electronic warfare system mounted on top of a BMD, while the BMD was operational. The reason that happened is because the drone was a fiber optic, and the BMD did not have any chance of taking down the drone using only electronic warfare. Similarly, these days, some of the FPV drones are operating at 27 megahertz, which is a very low frequency, and many of the counter-drone systems that we see in the market today are not capable of jamming in that frequency. There is a lot of technology adoption happening vis-a-vis the drone manufacturing, be it in the field or out of the field. People are using CRPA antennas, which are GPS-denied active antennas. They're able to circumnavigate around any GPS jamming. That's how some of the drones have come across the border, especially the RTK series. There is FPVs with 10-kilometer long fiber lines, reminiscent of the older wire-guided ATGMs like the Faggot and the Malyuktas, and as well as in-field manufacturing for attrition replacement. There are some drones which are capable of having onboard computer vision. These days, NPUs, which is neural processing units, have become so small that the drones actually have such systems on board, even if it's an FPV. So the capability of a smaller and smaller drone to be able to circumnavigate around your electronic warfare systems is quite high. And that's the reason why you have to look at a networked approach with multi-sensor and multi-effector capabilities. So this is just an image talking about different communication channels which a normal drone has, not the kind of drones that we are seeing today. There are some drones now operating on 4G, 5G LTE, where there is no 5.8, 2.4 navigation channels. There are some drones which are not even operating on GNSS. They don't even have onboard GNSS. There are some drones that don't take GNSS from the antenna, but they take it from RTK signals. There are some drones which use 4G LTE SIM cards to take GNSS RTK correction data from the internet. So you can't actually block them. Now there are some drones which have onboard cameras looking at the sky, navigating using stars, celestial navigation. You can't jam the night sky or the day sky for that matter. So there is a lot of variety when it comes to drones. Now the question is, how do we actually intend to take them out? First of all comes the detection systems. Passive detection is all the rage, was all the rage, but now active detection systems have to be incorporated in the layered defense system that has to be built, be it radar, be it EOIR, be it thermal with laser range finding. The problem is that as we go to the next slide, you will see different detection systems. I would like you to check out the bottom part, the weaknesses part. That's what matters, not the everything else. It's the weaknesses that matters. Every effector has a strength and a weakness. EOIR works really good when it's clear sky, but in extremely cloudy areas, high altitude, foggy areas, it falls flat. Radar works really well in open areas, in mountainous regions, there is problems. As it was already said, acoustics, it works really nice in open silent areas, but in very windy areas where there's a lot of noise, that again falls flat. But the point is that we cannot get disheartened about it. You have to utilize multi-sensor approach, use different sensors, combine them together, and create a holistic data set out of it. It need not be a vehicle-mounted system. It can be a very small backpack-mounted system too, but it is what it is. Similarly, when we come to effector systems, again, I would like you to look at the weaknesses column. Everything has a strength and a weakness. Electronic countermeasures, especially jamming, white noise jamming, spoofing, these worked very well with, as my fellow panelists said, entertainment drones. But now, when we are looking at specialized drones on the border, especially the DJI RTK 300 is one of, Matrix's 300 is one of the favorite drones for dropping drugs. It's a massive drone. Jamming it is extremely hard, and it has DFS functionality, which is dynamic frequency switching. So if you jam one band, it jumps to the other band. A lot of things are there. So these days, the first two effector methods are not very effective, sadly, as it has been seen in Ukraine and Gaza. Now, you may have seen things about ground-based net capture and air-based net capture. Sounds really good, but extremely hard to scale up, especially against swarming drones. You can't have 30 of your own net capture drones flying around trying to catch the other. It's not a cat and mouse game in the sky. It works well for bigger drones, but for smaller drones, again, as Curtis LeMay used to say, just one bomber needs to get through during the nuclear war paranoia. And that's what you're looking at today. A single drone needs to get through with an FPV warhead, and that's it. Then comes ballistic projectiles and directed energy, which are showing a lot of promise these days, especially next generation ballistic projectiles, which can be either a small missile that is launched for high value targets, or a head type munition, especially with proximity fusing fragmentation rounds for 23 millimeters, 30 millimeters, 40 millimeters, things like this. Even there are talks for fragmentation rounds for 12.7, but that's ways to go. But that is one of the promising areas where the cost to kill ratio is quite cheap and the effectiveness is high. And the third is, and the last is directed energy, which we are getting into the domain of would be, could be, should be. Microwave-based high power energy and laser-based high power energy is one of the new emerging domains, but the problem with these systems is they are not man-portable. Ballistic capability can be man-portable if mounted on a soldier's assault rifle, but then your kill, or a shotgun, but your kill distance is less than 500 meters for a FPV drone, and that is really cutting it close. So hence the problem there is a lot of issues when it comes to actual effector systems, which are effective at taking down next generation drones. But this requires continuous research and it requires a network capability. This is just some of the images. I'm sure I don't have to go over everything, especially for this August gathering. But usually a system has optical trackers, directional antennas, RF antennas, radars, things like these. Like it's a simplified network architecture, but not very effective in today's day and age. This is the image that I would like to show, especially when I talk about a complete effective networked anti-drone coverage system. This was created by the US Army for their base defense. As you can see, it's a network of different sensors. It's a network of different effectors. It includes kinetic kill. It includes captive missile-based systems. It includes a head-type munition. It includes high-power microwaves, everything. This is the kind of system that you are looking at if you want to defend against a robust, resilient, GPS-resilient, autonomous Chinese swarm coming at your borders. But again, this is cost to kill ratio and all has to be defined and has to be seen how effective it is for your needs. These are some of the high power microwave systems that are already in service, especially the Epirus, which has demonstrated its effectiveness against a massive drone swarm. It is a microwave based high power system, so not exactly a jammer. It fries the electronics on the drone. It can also be mounted on a drone or a 4x4 ATV. Similarly, and this is one point that I would like to make, smart EW jammers is what the future looks at. Fixed frequency EW is dead. There is no point in buying obsolete jammers anymore because the drones can jump around in frequencies. So unless and until your jammers can jump around in frequencies and operate on DRFM based technologies, fixed frequency EW is dead. And finally, just a couple of kinetic kill measures, such as the Raytheon Coyote missile, 40mm gun with a head munition, 35mm with a head munition. Last but not the least, these are some of the in-field modifications that have been done and have showed some promise in Ukraine. We see drone-mounted nets, drone-mounted shotguns. We see shotguns in hands of frontline soldiers. We see multiple barrel shotgun MLRS systems, apparently, but they are quite effective in close range. But then again, these are piecemeal substitutes, not exactly the kind of things you want your soldiers to depend on, especially if they're fighting a war. So the question is it reject modernity and return to tradition? Should every platoon start getting a shotgun to protect themselves against drones, or are we looking at a different kind of capability when it comes to protecting our soldiers? And that's the end of my presentation. Thank you.
The chair, esteemed co-panelists, DG CENJOWS, veterans, officers, ladies and gentlemen. Jai Hind, good afternoon. It's a challenge, post-lunch session. Nevertheless, and when I look at the watch, actually I'm left with only 1 more minute as per my original time. And I think that should be actually good enough because all that what I had to say has already been said. So now I have to see that what more can I actually talk about it. Well, my previous speaker has really covered it very well, and I'll just go on to the how it has got evolved. We all are aware that primarily in about last 3 to 4 years, starting from very, very basic measures of say, visual detection and concealment and just firing the small round, whatever weapon was there with you, and to coming up to right up to the stage of DEWs as of today. But when we look at it as a user, some important lessons. The reaction time is very, very less. And especially now with the FPV drones coming in, the reaction time with the user is very, very less. And inherent capability, therefore, is required by all elements. Because if we are looking at going by the way Ukraine, if they are saying 1 million drones in 1 year, that's what they're going to be using. Then look at the amount of proliferation which is going to take place, and therefore, at what all levels do we need really that counter-UAS capability? Do we have it only, say, at a sort of those larger umbrellas? Will they not be penetrated with the kind of counter to those technologies being developed. And therefore, the need to have with maybe every soldier, when we talk of that drone with every soldier, that's drone like an eagle on a soldier's arm. That's what the army is talking about today. And similarly, I think maybe we need the counter-UAS systems also. Not exactly the same, but almost in some ratios similar to that. Passive AD measures will always remain important. The short-range systems for large quantities, and when we look at it, the soft kill and DEWs are the most actually cost-effective option. DEW, yes, initially very cost-prohibitive as a system, but when it comes to the cost per engagement, that is of course quite less. Surge capability. Now, generally we talk of surge capability in terms of production, but what we have witnessed in the ongoing Ukraine war is it's not only production, it's also when every 2 to 3 months there is a new system coming up. There is a new counter to that getting developed. So the surge capability which we need is actually also in the R&D, or rather I'll say right from that TRL 0 to TRL 9, within a short span of the 2 to 3 months is the kind of pace at which this R&D surge is required to be taking place. And of course production, once it comes to actual war, the way we have seen the requirement would be, that is what for the industry to see that how we are able to build that surge capability. All this has already been covered, various means of identification and various means of interdiction. I'll not go into it. The challenges, so far as when we look at each of those components, the old system of using the radars and all will not really work because of the low RCS, since these radars were never actually designed for that. And this even now is going to become further compounded when there are technologies being developed to even further reduce the RCS. And so therefore, compared to its actual RCS, with those kind of technologies, the RCS which we are going to be actually seeing on the radar is going to be even further lesser. And already come out very clearly that no single technology can actually meet the solutions. It has to be a mix of various kinds of technologies. And of course, decentralized control, because the way the proliferation is, we'll have to look at decentralized control. Now, while we have spoken about the various systems and all, when we look at the indigenous counter-UAS capability, if we see what is shown in green, is the 3 aspects where there is, I think, we are quite good at it, even if whether we look at it the R&D or with the academia or with the industry. That's in terms of jammers, the remote control weapon stations, and net guns. Another 4 of them where we are somewhere there, but may not be, say, fully indigenous. So we need to really work on it. That's in terms of EO devices, the GPS spoofers, the cyber takeover, and the interceptor drones. One category where actually something lot is required to be done is the VSHORADs, the laser beam riding. Now that is one where I think we are still at the nascent stages and we need to work a lot on it. Now, so far as the services are concerned for us as a user, the requirement, so far as the counter drones are concerned, we're looking at detecting them at a range of approximately about 5 kilometers and then be able to engage them with the soft and hard kill systems, maybe anything up to 3 kilometers and lesser than that. And so far the counter RPS are concerned, we look at about 5 to 10 kilometers of range where we should be able to detect and then thereafter, of course, destroy them. And as a user, when we look at it, the different brackets, what is shown on the left, on the top left, the x-axis gives out the range in kilometers and the y-axis gives out the altitude. So broadly speaking, so there are 3 brackets, the deep bracket, medium bracket and the low bracket, and further one ultra low bracket. So we are looking at, say, so far as the low bracket is concerned, anything up to about 2 kilometers of range and at an altitude of about 1.5 kilometers. In the medium bracket, up to about 5 kilometers of range and 5 kilometers of altitude. And of course, beyond that is the deep bracket. And the various, this is because the feasible engagements at each one of these are the ones which are shown down below. So when we see at the low bracket, it's about 0.01 square meter to 0.05 square meters is the RCS which we should be able to detect and then accordingly have countermeasures for that. And in the medium bracket, it is 0.02 square meter to 0.1 meter square. And of course, in the deep bracket, beyond 0.1 meter square. The various methodologies which can be used in various combinations of the sensors, soft kill and hard kill, are the ones which are shown on the right. So, so far as if we use medium as the basis, we can say that other than the man-pack jammers in the soft kill, and other than the RCWs and net guns, rest all systems are generally applicable. And there's a little variation so far as the low and the deep bracket is concerned. Now, finally, when we look at the configurations for the Indian Army, you know, there was a mention about that the man-pack jammers and all, that really how much they can be really effective or not. And then having those bigger DEW systems, which have very high requirement of power, and then that power to generate at the high altitudes with the kind of road infrastructure available over there, will they be really able to reach there or not? So each kind of systems has got its own limitations and capabilities. At the same time, our requirements have also got a wide range. It is right from a foot soldier who is going to be actually operating on the LAC in that arduous terrain at those altitudes, wherein even his own load carrying capability also reduces drastically because of the lack of oxygen. Leave aside the functioning of the equipment itself, which because of the high altitude, the rarefied atmosphere, the icing taking place, the high wind speeds and all, because of which the performance of the systems also go down. That is more applicable for the drones as such. But even when we look at the counter drones, in terms of power requirements, there's a heavy requirement. So therefore, it's a mix of all these kinds of various 4 configurations which are shown over here on the slide, which we are looking at. And in various quantities and all, man-pack or man-portable systems, which can say have any kind of sensors like EO/IR sensors or RF detector, and effectors in terms of say jammer guns or omnidirectional jammers or net guns, or maybe even the drone interceptor also. But again, it will all depend on at what altitude we are expecting them to operate. Maybe all of them are not required to operate at that 17,000, 18,000 altitude. Some of them may be at about 14, 15,000 only. So accordingly, a combination of these various systems is what is required as a man-portable system which a soldier can carry. The next one is, say, otherwise the portable systems, which can be, say, even the vehicle-based, the ATV-based systems. For example, using the sensors of, again, EO/IR, RF detectors, and the various kinds of effectors, including, in this case, the DEW also. Because that is what you see even in this one of these, the extreme left, that is where a DEW is being used in that photograph. And intentionally, I'm not using the photographs of indigenous equipment, but only the foreign equipment, so that nobody feels that my firm's photograph was shown and why so-and-so firm's photograph was shown. So therefore, to keep out of that controversy, I'm intentionally showing only the photographs of the foreign equipment. Okay. And when we look at the platform-based systems, that is like, let's say, to have it on every tank or BMP, like that. So in that case, effectors can be in terms of jammers or spoofers and the RCWS. And finally, as an integrated system, when we look at it, it is combining all these various kinds of sensors and a vehicle specifically customized for this purpose only. That is, which can have a combination of various sensors, including EO/IR, RF detectors, active radars, and integrated early warning. And the effectors, right from jammer, spoofer to even cyber takeover, an air defense gun or the missiles, and of course the directed energy weapons also. But then yes, it remains quite a challenge so far as the directed energy weapons are concerned, because the system which we have as of today, developed by the DRDO, the form factor is quite big. To be able to get that form factor into a tracked vehicle of the kind of configuration shown here in the images is really a challenge, and for which even the foreign countries are also working upon. So with that, I come to the end of my presentation, a brief summary of basically what all we are looking at. Thank you.
Thank you, Nilman. Like you said, post-lunch session. Let me tell you tell you an anecdote, Nothing to do with this counter-UAS system, but it's got some logic in it. Way back in 1912, there was a physicist from Germany called Max Planck who got the Nobel Prize for Physics. And after he got the Nobel Prize for quantum physics, actually, he was roaming around all over Germany giving a talk on quantum physics to various universities. One by one he was going. And accompanying him continuously on that trip was his driver. His chauffeur also was there, and he would go everywhere. And there were no social media, no photographs, so no one could actually trace, no one follow up. So he would go to the university, go and give the lecture, and the driver, the chauffeur, also go and sit in the lecture. So he had heard the same lecture 6 times. So on the 7th time, he was going to University of Munich. So now the chauffeur told Max that, Max, don't you get bored? Same damn lecture you have given 6 times. I have also known it verbatim now. I think I can also take the lecture. Max himself was quite bored of the lecture, giving the lecture, so he said, sure, boss. Next university, you give the lecture. This is a true story. You can Google it. And so in the next university of Munich, Max wore the chauffeur hat and sat in the audience, and his chauffeur gave the talk. Verbatim talk on quantum physics. When the talk finished, one smart guy in the audience, a professor, asked a question. Now when the question was asked, the chauffeur looked at the professor, then looked at the chauffeur, that is Max, and said, such a big university, such a simple question, my chauffeur can answer it. So the chauffeur got up and answered the question. Now, what's the point of the story? The point of the story is, this is a management concept called chauffeur knowledge. It is very easy these days, more so these days, with seeing 1 or 2 YouTube videos, reading a little bit, attending 1 odd seminar, to gain chauffeur knowledge about a subject and then masquerade as an expert. And, it is especially true of a certain variety of people. I hope there are none here, news anchors being one of them. So, anyway, and also others. And also, I think this malaise also sometimes affects senior officers like us. So, I definitely don't want to masquerade as a counter drone or a drone expert at all. The experts are on my right and left. And possibly they know the subject better than me. So, I do not want to, give any particular more, I would say, expert comments on that. All I would say is that I also spoke, once I got the topic, I also spoke to some people in 14 Corps which are dealing with altitude there. And they also said the same thing what Shri Mukesh told us, that there is a live problem of Pakistani and Chinese drones which are coming across, and the ability to jam them or drop them or to cyber hijack them is pretty limited. And the reasons have been well illustrated by the speakers here. I think he made a good point about networking of drones that could be taken on, which I think even General Maan alluded to circumvent the problems we are having. I think an out-of-the-box solution is something like what happened in the nuclear arms race, that since you could not counter it, you just made more of them. So I think that's one way of doing it, I think. If the other guy has 1,000, let's make 10,000. And let our drones only be the counter drone. And maybe that's one way of doing it. And if the cat and mouse game is going to continue. So having said that, I think I'll end here. A panel was very, had put the point across. General Maan has told the industry what they need from you. So get to work. And I'm sure then the twain can meet the request from the supplier and the user. Now, sir, if there's time, we can take some questions or... Okay, please, go ahead. If anybody's got a question, because Vice Chief, I think, had to come. Yeah, anybody, please address the panel, yeah. So he's taking time. I know, I'll give 5 minutes. No, it's only 5 minutes. Yeah, please go ahead.
My question is to Mr. Navneet Singh. We have talked about the hard kill as the last resort for the if the other techniques are not working like EW systems, then in the hard kill, just the ballistic trajectory won't work every time because it's obviously it is in the motion. So when we need to have the guidance to it, then do you see the future in that? Because if you want to have the guidance, then INS has to be there on board, and the sensor has to be there which tracks it continuously. Then won't it become a small missile itself? Then it will again cost a lot.
So yes, that is a correct point actually, because so yeah, that is a good point, and it depends on the kind of drone that you're trying to shoot down. If you're trying to shoot down a bigger RPAS, or you're trying to shoot down a much bigger drone than a small FPV, then yes, you need to take into account guidance systems on a missile. And that's what's been happening actually. If you look at the overall global trend towards protecting high value targets, the cost to kill ratio is very high, but the effectiveness of the kill is quite high. When you're protecting a very high value target, cost is not a problem. If you're just protecting a single soldier, then anyways the enemy is also not going to crash a TB2 Bharat car into you. Enemy is not going to do that. So to kill a bigger drone, a missile-based system is a good defense, and that is what Raytheon, Coyote, and C-Scepter, and even if we see Anduril's drone, Anduril's anti-drone system is there. And yes, the cost is there. So it depends on what kind of drone you're actually trying to shoot down. Using a missile to shoot down an FPV, that's like the analog of, the Americans using a $40,000 Javelin to blow up a $1,000, Talibani truck. So that's not a correct analogy. For that kind of a drone, you use a small shotgun. And when you're using a shotgun, you don't need to, guide your shotgun with INS. You need to use eyeball Mark 1, and that usually works out pretty well. So I hope that answers your question.
Just another addition to that. We did try those hard kill options. One para gave us an improvised solution once. They mounted 3 Pika machine guns because we had the lat long, and they tried everything. They must have fired 200-300 rounds, but it didn't come down. It did come down once, and that was brought down. Our own drone was brought down by a terrorist. We tried to look for a terrorist in a ravine area near Buntole Plaza, and since we had got it very low to observe the movement, he could bring it down. But otherwise it is difficult. These drones come at night, the drones carrying weapons, they fly at a height of 300 meters. Bringing it down is not very easy. So hard kill option is a very, very average kind of an option.
Is there anybody else? Yes, please. We'll give them a mic also. Yeah, after him. Yeah, he's there.
I am Group Captain PK Mishra. My question is to you, Mr. Navneet Singh. You mentioned use of 5G and RTK. 5G may not be usable. First of all, it might not be applicable or available in the battle space. And secondly, ranges are not available in that. And thirdly, attenuation is very, very high. The point you mentioned about RTK will not be available to you in the battle space.
Agreed with you that not available on the battle space. And obviously, when you're fighting a war in open plains, there are no 5G towers around. But my point was mainly towards the city-wide warfare that's happening in the battlefields of Ukraine, where 4G and 5G networks, and obviously not 5G, 4G networks are still operational. And the anecdote that I gave you of the drones using 4G-based RTCM correction data, that's based off an actual operational event that happened 3 months ago, where the drone was carrying a 4G dongle. If you remember, there used to be internet dongles that you could buy and put your SIM card in it. So they use that as a network correction device for GPS jamming protection. And if you go to SparkFun, which is an American hobby electronics website, you can buy the RTCM module, which works over network. And that gives correction data over network to you. So what I said was based off warfare that's happening inside the cities, warfare that's a terrorist may use such a network because he may be attacking you inside a city. So that's why that point was raised, and that point is quite pertinent. Even today, in Ukraine, Ukrainian Baba Yaga drones, if you have heard of relay drones, they carry backhaul networks on 3G and 4G. Because when Russian electronic warfare is jamming everything around you, usually they do not jam the 4G and the 3G networks because their soldiers are also dependent on using mobile phones in such a contested battlefield. And locking down a tower and destroying it is usually not in the favor of anyone on the battlefield. So those are open channels and people are using them. So that was my point there. I hope that clears you up.
So may Navneet, just want to understand, we are talking about advancements in counter-UAS system. You as a developer, where do you find the challenges in terms of input from users and the development of core technologies in India? And the second question to my uniform personally, when I look at, like I meet a lot of counter-drone developers, including from other parts of the world. One thing which is very, very different from theirs and ours, even US border guards when I talk of, so when I'm talking of CAPS, a lot of their projects are handheld by the uniformed personnel, not only in terms of like we have started IDEX and these are in great initiatives, but some of those tasks work with them on a spiral development trajectories. So to give you example, Fortran, when last I met him about 3 years ago, he was on the 5th project being funded by and collaboratively worked by the Army Research Laboratory. So don't you think there's a little gap, even when we were talking of, when he was saying we will test it, collaborate?
We got your question. Let him answer the first part about that and about...
Yeah, so mainly when I said that we need more feedback from the user, and we are talking about having integrated research initiatives with people deployed in the field, along with, let's say, I'm a startup and I want to work, I have something that I want to work on, and it is working in the lab. I would like it to be deployed in the field along with and of course there are security issues and, self-preservation issues that come into fore. But there has to be some way where we can test the developments and do the iterative development cycles in the field to understand exactly, see, for example, I'll just say this, right? RF jamming, spoofing is basically black magic. It may work in the lab today, but tomorrow you go and you change the painting on your wall a little bit and it will not work anymore. But that's the whole point. Multi-path reflections, different kind of attenuations, things are different. Your radio waves may jam a system very well today, but tomorrow you may realize, oh, ye to ped ke through jam hi nahi hota. But that you will not know because you tested it in your sterile lab and you're very happy that it works. That's the whole point. If you need actual iterative development cycles, you need to integrate innovators along with you at the areas where you want to operate. You do that and then you see how, and not only that, not only does it help the developers, the innovators, it helps the user, because the user now has actual people who were part of the development cycle of this product, who even if the innovator says, okay, my job is done, I'm leaving, bye. The people who worked on this can then take up the mantle and do their own iterative development cycles as the threat scenario changes, which will change every single day. The Chinese are already ahead in this, and you will be looking at a massive issue if we do not do this. But next point.
So far the aspect of the hand-holding the industry is concerned, I think we have come a long way now. Right from taking the industry and academia to our forward-most areas, to acquaint them with the kind of operational environment we have, with the kind of challenges the terrain and the weather poses over there. So therefore, what is the kind of equipment they need to develop? And then thereafter, say even launching things like our problem statements, the latest one, compendium of problem definition statements we have launched during this Aero India. And then getting them developed through various means using all these, whether IDEX, TDF, MAKE, and even some of them through our Army Technology Board projects. And while they're getting developed, we have a system wherein we have a nodal officer from a Cat A establishment who is one-to-one in touch with that developer and available to him on almost daily basis on guiding him as to what exactly the requirement is and in case any support required. So all those measures are being taken, sir. The aspect of spiral development, yes, that also is now what we are doing. In fact, for example, if we see, not specifically say counter-UAS system, but otherwise I'll say as an approach as such, say in IDEX, the first 4 contracts which we signed, rather the 5 contracts which we signed, in none of those cases, the developer was actually able to meet the requirement which we had set in for. It was little lesser than that. But still we have gone in for procurement of limited quantities so that we carry out its field exploitation. While the field exploitation is going on, the developer will continue with his further development so that we will learn as to what else we require, or maybe something which we are asking for may not be required also. So that then accordingly we refine our requirements while he is working on it, and simultaneously again we meet on it, and we have ultimately the thing which we require. So that is one aspect of, say, spiral development. The second aspect of spiral development is like, let's say, wherein ab initio we are asking for something at a lower level. And then we are looking at that, okay, in the second tranche, we'll go for a little higher, and maybe third tranche further higher. To quote you an example of that, say in our FRCV case, we are going to get our entire requirement over 3 tranches. So in make 1, the first one which we have set in for is what can be done by the industry today. And in the second one, what is little futuristic. And the third one will be finally, the second will be state of the art, and third one will be actually futuristic. So that's how we are looking at the spiral development part of it. And I think we all are learning. It's a daily learning process, learning from each other and trying to further refine, evolve our procedures so we can get the equipment at the earliest. Thank you.
Yeah, so just you have a very valid point. Actually, the DRDO systems which are there at Amritsar border, they work really well on DJI Mavic kind of things which carry drugs. They have hardly worked for drones which are carrying weapons. Those drones are autonomous assembled drones, parts from various parts of the world, something from China, Hong Kong, London. They are all assembled. Nobody tries it on those. Nobody tries to make another drone of that type and tries to experiment on that drone. Everybody comes with their own drones, the drones which follow standard protocols, experiments and shows us the demonstration on that. But on actual drones which carry weapons, nobody has tried to do that. So you have a very valid point that we should actually work together. I should share the specifications of the seized drones with you. You should try to make a drone like that and try to use your counter drone measures there.
Hello, sir. Excuse me, sir.
I think we have
sir, one question. Actually, now all are talking about okay, drones can fly high altitude or a little bit detectable range. It's okay. Suppose the drones are hybrid. Okay, it can be fly, also it can be rover in ground, and also in that case, means for example 5-meter altitude height or 2-meter height, and in that case how it can be counteract or how can it will be detectable, and it's in the small size, means nano level drone or micro level drone below 250 gram range. Any solution is there?
just give him 30
Means
seconds.
1 kilometer range.
But otherwise, tea break.
If my aunt had balls, she would be my uncle.
Also?
My point is that such hypothetical scenarios, having a drone that can crawl, that can fly, all these things are quite good. But the actual functionality of such drones in use cases are very limited. And second, when the drone is flying, you try to shoot it down. And if the drone is walking, you try to shoot it off. That's the only two things that you can do for such drones. Other than that, the same constraints apply when we talked about autonomous drones and frequency, fixed frequency, agile frequency, things like that. So the same constraints apply to that also.
It's, everything is.
No, I think we'll leave it here. We can talk in the tea break. No problem. So I'll close the session. There's one more session, and there's also a tea break after this. So all I can say is thank you to my co-panelists, and I'm sure you can talk to them in the tea break. Don't talk to me because I'm the chauffeur. The Max Planck ke baithe.
Thank you, panelists, for this engaging discussion emphasizing on strengthening our defense grid against emerging drone threats. May I now request Lieutenant General Vipul Shinghal, Deputy Chief of Integrated Defense Staff, to present mementos to the esteemed panelists. Shri Mukesh Singh, Mr. Navneet Singh, Major General C.S. Mann, may I request DG CENJOWS to please present a memento to the chairperson. I request the dignitaries to please come forward for a group photograph. Sir, in front of the stage. Yes.
Let's go do it fast.
So from here, you could join from here.
There is an extremely requirement for tea break at this moment.
This concludes session 3. We will now have a 30 minutes tea break and reassemble at 1600 hours for the next session.